In this video, we're going to be talking about and showing how to graph solutions to inequalities. We're talking about one variable inequalities. We're going to start with the basics here. A solution is a value that satisfies or makes an equation or inequality true. So we have to start with what a solution means in that foundational understanding. So everything that we're going to graph, there's going to be multiple solutions to these inequalities, multiple values that will make it true. Let's start with some of the basics. When we look at the signs, we are always comparing two values. So I have boxes to represent that. This would be read as this box is greater than or equal to, this line being down here, this second box. Notice the difference. If there's not a line underneath, then it cannot be equal to it. It has to be strictly greater than the first one. We could also read this from right to left saying this one is less than the one on the left. The other items, we have less than or equal to or less than. So for example, 5 is less than or equal to 6. 6 is the larger value. The mouth gets the larger value. It could also be equal to it. So one of those conditions has to be true. It either has to be less than or it could be equal to it. The second one is strictly less than, so 6 is less than 10. Would satisfy that, would make that true. Now that we have these, if we have the equal to, that means that the point is included in the solution. If the point's included in the solution, we're going to use a filled in circle on these graphs. If it's not included, then it will not have the equal sign underneath, the partial equal sign. And it's strictly less than or strictly greater than. And this point is not included in the solution, so we just use an open circle to indicate that. Let's look at some examples. We're always going to use test points to see where the solution area is. X is greater than 5. We know we're comparing it to 5. Based on the previous slide, it's an open circle on 5. Now we're going to choose any point that is not on this to see where our shading or where our solution area falls. So I'm going to use a test point. I'm going to choose the test point 3. I'm going to substitute 3 in for x in the equation. 3 is greater than 5. That is false. 3 is not greater than 5. So we know that the point 3 is not in the solution area. So we have to do another test point until we get a true statement, which would indicate a solution. So I'm going to try 6. 6 goes in for x. 6 is greater than 5. It is. 6 is in the solution area. We know that every other value on the side, and if we wanted to test them, we totally could, but we're going to shade it this way to indicate that is the solution area. The next example, we're going to have to use a test point as well. So we know we start at -6. We fill in the circle because it can be equal to it. And then we're going to choose a test point that is not on -6 to see where our solution area lies. So I'm going to choose a value -7. -6 is greater than or equal to -7. If we're unsure, values on the number line are always greater as we move to the right. So -5 is greater than -6. -4 is greater than -5. So -6 is to the right, so it's actually larger than -7. This is actually a true statement. So our test point was -7. We substituted that in. It made it true. We know our solution area goes this way. And that's how you graph these inequalities.